Okay, this is part 2 of the sum and difference formulas. So let's look at this example. It is known that the sine of alpha is 1/2. So I know that the sine of alpha is 1/2. And that alpha is between, let's see if we can get this clear for you, and that alpha is between, there it goes, it's trying to clear up. There it is. Okay, the sine of alpha is 1/2, and that alpha is between pi over 2 and pi. So that means that alpha is going to be between pi over 2 and pi. So that's going to be in quadrant 2. And we know that the cosine of beta is equal to -1/3, and that beta is between pi over 2 and pi. So both alpha and beta are in quadrant 2. They want us to find the exact value of the cosine of alpha. Okay, so let's say that alpha is over here in quadrant 2. So this is going to be my alpha graph. And I know that the sine of alpha is 1/2, which is going to be y over r. So y is 1, r is 2. And so if I want to find out what x is down here, I'm going to do Pythagorean theorem, which is 2 squared minus 1 squared equals x squared. So that's 4 minus 1, which is 3. So that means x then is the square root of 3, positive and negative square root of 3. And we're going to use the negative square root of 3 because we're over here in quadrant 2. So now we can find out what the cosine of alpha is. The cosine of alpha is going to be x over r, which is going to be the negative square root of 3 over 2. Now you may not have had to do all of this work if you realized that the sine of alpha being 1/2 is on my unit circle. Okay, so all right, let's look at letter B. Letter B is asking me to find the sine of beta. So let's go over here and draw a graph for beta. Okay, for beta, we've got that beta is between pi over 2 and pi. So here's our beta over here. This is my right angle. All right, so now let's look at what we know about beta. Well, we know that the cosine of beta is -1/3, and that's x over r. So this is -1/3. So now we can come over here and find out what y is. Pythagorean theorem. Oh, that's not right. That should be minus -1 squared. Sorry. And that's going to equal y squared. So that's going to be 9 minus 1 is y squared. So 8 is y squared, and y is the positive and negative square root of 8. Okay, and if you simplify that, that's 2 square roots of 2 for y. So this is positive 2 square root of 2. Okay, and so now we can find the sine of beta, which is going to be 2 square roots of 2 over 3. Okay, now all of that is actually in this slide right here, and I actually, on this slide, they actually did it a different way. So I would, you can look at this slide and determine if you prefer to do it the way that they did it here, or using Pythagorean theorem. Okay, it's really the same thing, the same idea, except that we're using the Pythagorean identity here on this slide. If you look right here, you can see that sine squared plus cosine squared is equal to 1. So the cosine of alpha is 1 minus the sine squared of alpha. That's what the cosine is equal to. Okay, from here, we just solved this Pythagorean identity for the cosine of alpha. Then we put our information in, and we got exactly the same thing. Most of us are going to look at it this way because that's the way we had learned how to do it previously. Okay, so, and then this is the same work that I just did on the paper. So you can take a moment and look over it and see that it's the same. Check it out, copy it into your notebook. Okay, and now we're going to look at letter C. Let me see if I can move this up just a tiny bit. So letter C is asking me to find the cosine of alpha minus beta. Well, I know a formula for that. It's cosine, cosine. So cosine alpha, cosine beta. Opposite sign, so plus the sine of alpha, sine of beta. Okay, so slide that up just a little bit. I don't want it to get too far away. Okay, now all I have to do is plug into my formula. The cosine of alpha is negative square root of 3 over 2. The cosine of beta is negative 1/3. Plus the sine of alpha is 1/2. The sine of beta is 2 square roots of 2 over 3. Okay, and now all I'm going to do is do my multiplication. So a negative times a negative is always a positive. 1 times the square root of 3 is the square root of 3. 2 times 3 is 6. Plus 1 times 2 square roots of 2 is 2 square roots of 2 over 2 times 3 is 6. And if you want to go ahead and add those together, you can have the square root of 3 plus 2 square roots of 2 all over 6. And that is the cosine of alpha minus beta. Okay? All right, last problem, and this will be the last that you have to copy for today. Let's look at it. This says find the exact value of the tangent of the sine inverse of 12/13 minus the cosine inverse of negative 3/5. Okay? Now the first thing that I want you to see here is that this is the sine inverse, so this is an angle. This right here is an angle. It's the sine inverse, the angle whose sine is 12/13. So I'm going to call this angle alpha. This is also an angle. This is the angle whose cosine is negative 3/5. So I'm going to call this beta. And since I'm subtracting these, I look and see that I have the tangent of alpha minus beta. So we're going to use our tangent formula here. So the first thing I need to know is what is the sine of alpha? What is the sine of alpha? Well, if this is the angle alpha, and this is the angle whose sine is 12/13, then I know that the sine of alpha is 12/13. And I know that this has to be between negative pi over 2 and pi over 2, because that's where my sine inverse is defined. Okay? Now we're going to find out what the cosine of beta is. Okay, the cosine of beta. We're going to do that next because we already know what it is. If this is beta, this is the angle beta whose cosine is negative 3/5. So that's going to be the cosine of beta is negative 3/5. And we know that beta has to be between 0 and pi because that's where beta would be defined since we're looking at the cosine inverse. All right, now what we need to do is we need to find the cosine of alpha, and we need to find the sine of beta. Because if we can find those, then we'll be able to find the tangent of alpha and beta, and we'll be able to find what we're looking for here. So let's find the cosine of alpha. So I'm going to come over here to the side, and I'm going to draw my little triangle. I know that we're in either quadrant 1 or 4, And since my sign is positive here, then I have to be in quadrant 1 because sine is negative in quadrant 4. So the sine is y over r. So this is 13 and this is 12. And so now I'm going to use my Pythagorean theorem to find out what x is here. So 13 squared minus 12 squared is equal to x squared. So that's 169 minus 144 is equal to x squared. And that's going to give me 25 equals x squared. So x is positive or negative 5. And since we're in quadrant 1, it's positive 5. Okay, questions there? If so, please write them down. All right, so now we're going to do the cosine, excuse me, the cosine of alpha. So the cosine is going to be 5 over 13. And now we're going to find the sine of beta. So beta is between 0 and pi. And since the cosine of beta is negative, then I know it can't be in quadrant 1. It has to be over here in quadrant 2. So the cosine of beta is negative 3 over 5. That's x over r. So this is negative 3. This is negative 5. And hopefully you know this is a 3, 4, 5 triangle. So we're looking for the sine of beta, so that's going to be 4 over 5. And now we can quickly and easily find the tangent. Let me scoot this up a little bit. I feel like it's too far down. And now we can find the tangent of alpha. The tangent of alpha is the sine of alpha, which is 12 over 13, divided by the cosine of alpha, which is 5 over 13. And that means that we have the tangent of alpha is 12 over 5. And now we're going to look for the tangent of beta. So the tangent of beta is the sine of beta, which is right here, the 4/5, over the cosine of beta, which is right here, the negative 3/5, which means that the tangent of beta is negative 4/3. Okay? Let me go ahead and switch this slide so you can see some of what we were doing here. Okay, now, if you didn't want to do it this way, you could just have looked at our triangles that we have right over here. Okay, our 5, 12, 13 triangle and our 3, 4, 5 triangle, and you can get your tangent. Tangent is the opposite over the adjacent, 12 over 5, and the opposite over the adjacent, 4 over negative 3. That's another way to look at that. Okay, now we're going to use our tangent formula since we have those two tangents, and we're going to look for the tangent of alpha minus beta. Now remember, because I'm going to slide back up here, because that's what we were originally looking for, was the tangent of alpha minus beta. Okay, so let's go ahead and do that. So what we have now is the tangent of alpha, and I would recommend that you write these down as you go, minus the tangent of beta, 1 opposite sine, tangent alpha times tangent beta. If you will write those formulas every time that you do a homework problem, by the time you finish all your homework, you won't have to worry about those anymore. You'll know them. So the tangent of alpha is 12 over 5, 12/5, minus the tangent of beta, which is negative 4/3. So we're going to subtract negative 4/3, divided by 1 plus the tangent of alpha, which is 12/5, times the tangent of beta, which is negative 4/3. Okay? And now we're going to go ahead and simplify that. So two negatives make a positive. If you find the common denominator here of 15, then you're going to end up with 56/15, because 12/5 is the same thing as 36/5 plus 20/5 added together. I mean 15ths. I'm sorry, I said fifths. 12/5 is the same thing because we're going to multiply here by 3 and 3 and multiply here by 5 and 5. So this is going to be 36/15 plus 20/15, which is 56/15. And then on the bottom here, we're going to have, I'm going to write it over here so you can see it. And then here we're going to have 1 plus, right here we're going to multiply and get 48 over 15, and that's going to be negative. And if I think of this as 15, this 1 as 15 over 15, 48, negative 48 plus 15 is negative 33 over 15. And then my 15s cancel when I invert and multiply, so that I end up with negative 56 over 33 for my tangent of alpha minus beta. Okay. All right, I need you to be sure that you are checking out this second part of the video, getting your notes down, and writing down any questions that you might have so that tomorrow I can answer them for you.